Hello guys, my name is Ono and today I'll be telling you how to solve this problem called JoJo goes to the market. This was the sixth problem of the Codewar contest which was held on 5th April. Now let's get to how to solve this. Given in the problem that we have a hero who's called Jonathan Joestar and he's going to the supermarket to buy apples. Now each of these apples has a different nutritional value and a different cost. On top of that, some of the apples might be poison, but Jonathan knows which apples are poison. So he does not want to buy those apples. He only has a fixed amount of money. Help Jonathan choose the apples with the maximum nutritional value, and he cannot buy the poisoned apples. So given the amount of money that he has, you need to make him buy the apples that have the combined maximum value. So normally if you wanted to start this problem, the first thing that might come to your mind is let's sort this array of apples based on the nutritional value. The apples which has the highest nutritional value, let's pick those up, then put them to the basket, and then we will get an optimal solution. But it's not the case, because if we have an apple that has like let's just get into an example, and that will be better. Let's take this case where we have this is an array of the cost of the apples, and this array contains the nutritional value. Now 6 the apple that costs 6 has a value of 310, and the apple that costs 4 has a value of 300. Apple that costs 2 has a value of 120. Now these has already been sorted in the descending order of their costs and the nutritional value. Actually it's all sorted in the descending order of the nutritional value. So if we choose the first one, the apple with the maximum nutritional value, which is this one, we are spending rupees 6 and we are left with 1. So we have spent 6 and we have got 310. But if we had chosen this 2, then we would have spent 6 but gotten 420 in return. So this was the optimal solution in this case. So what we have to do is we have to find the answer to all possible subproblems, like what would be the maximum cost with some amount of money which is less than 7. Those of you who are familiar with dynamic programming know that this is a very classical example of a 0-1 knapsack problem. It's a 0-1 knapsack problem. You can go to Google and you can search 0-1 knapsack, and the first link you will get is the Gigs for Geeks video website link, and over here you can read about the 0-1 knapsack problem. I will link a wonderful video describing this problem, the 0-1 knapsack problem, and you can go to watch it before continuing to see the video. And those of you who don't know about how this works, I would sincerely suggest you all to go and check out this algorithm, this dynamic programming problem, before you come and watch this, because this is just a twisted version of this 0-1 knapsack problem. It just has some extra variables, some extra conditions. So what are those extra conditions? It's this poisoned array. This array that has the indexes of all the apples that are poisoned. So what we can do is we can take this poisoned array, and we can do two things. We can either remove the poisoned apples, or we can assign a very high cost and a very low nutrition to the poisoned apples. So what happens during the knapsack procedure is that the ones which have very high cost and low nutrition are automatically left out, so they are not considered in the final answer. So which one of these approaches is better? If you want to remove the poisoned apples, that has a overhead time complexity if you are doing it in Python, and if you are assigning the fresh apples to a new array, that will lead to a higher space complexity. So the more efficient approach would be the second way, which I am going to implement over here. So let's do this. Let's take the inputs first. What are the inputs? Let's see. We have three variables, n, b and m. So int n equals sc.nextInt. Alright, so n here signifies the length of the array, that has the cost and the nutrition. Okay, b is the length of the array that has the poisoned apples indexes, and m means the money that JoJo has. So we also need three arrays. So first array will be called cost ARR, let's say, and that will be of size n. Oops. We have a second array which is called the nutrition ARR, and that will be of size n again. And the third array will be called poison. Let's call it poi ARR, and this will be of size b. Now let's take this input. For int I equals 0, I less than n plus plus I, cost ARR, the ith position will be taking the input. Alright, I'll be copy pasting this. This name will be changed to nutrition, and this will be poi, but it will be of size b. Alright, now we have the inputs in place. Now what we are going to do is we are going to change the cost and the nutrition of all the poisoned apples to very high and a very low value respectively. So what we will do, we will use a for each loop to loop over all the elements of the poisoned array, and then we will use this to make the cost of that particular index very high. Over here our value can never exceed 10 to the power 5, so we will give something which is more than 10 to the power 5. Over here I have given it's in the range of 10 to the power 6. Yeah. Now for the nutrition I'll be giving a negative value, so that it is never considered. Like taking it will be like if we take that nutrition apple, it will harm our result. That's why it won't be taken into account. So I guess this takes care of the poison elements, and now we only need to apply knapsack, and we can simply do that by I think it will be better if I just copy paste it from here. That should be fine. Oops, I copied C++ code. I need to copy the Java code. Yeah. So this is our knapsack, which is building the table and using dynamic programming. They've used a custom function, but I can use math.max. It will be of no issue. And so our final result will be knapsack of. Okay, knapsack takes 4 arguments. First one is w, For in our case, this W is nothing but the amount of money that JoJo has. WT is the array of the weights, and for our case it's nothing but the cost array. And value is nothing but in our case a nutrition array, and n is the size of the array, and which is the same in our case. So we will be printing this system.out.println result. Okay, so I guess this should work. Let's run this on our sample case that has been given over here. Let's run this over here. Yeah, 694, we get a 694. So I hope this should work. Let's submit. Okay, let's see if it works. Yeah, so it's the correct answer. So what is the time complexity of this? We need to ask ourselves. So over here we can see that this all these functions are linear time operations. Input. The most time comprehensive function is this knapsack function, which is a double loop. The first loop runs from 0 to n, and the second runs from 0 to capital W. Capital W is the cost. So I think the time complexity of this function will be O of n times W, and the space complexity will be O of, we are using a DP table which is of size n and W, so yeah, it's also n and W. Alright, so thank you for watching this video. I hope you understood how to solve this problem. That's all.